So today we're going to get to where we're actually building the chemical reaction. We're going to be presented with our two reactants, and we have to predict what the products are going to be of our chemical reaction. Okay, when we do this type of work, we're always going to assume that we're working with a double displacement reaction. Okay, so what happens in a double displacement reaction to the cations and the anions? They do what? They switch places, right? They switch places. So in a double displacement reaction, we will always see the cation and the anion just flip-flop. Okay, the outsides come together and the insides come together. So there's some predictability when we do these problems about what our products are going to look like, but we still have to build them from scratch. Okay, and so I'll talk about what that means as we go through here. But when we're doing building reactions, we're predicting the outcomes. We're predicting both the actual products and the quantities of those products. Okay, how much of our products can we use? Okay. Double displacement reactions are the easiest for us to work with on these because we are able to just switch the cations and the anions. So we're going to just start with one here. It says sodium nitrate reacts with calcium fluoride to create what? Right? We're going to start about what that might be. Let's just say it in words first, and then we'll start putting them into their chemical formulas. So if I'm going to predict that sodium nitrate reacts with calcium fluoride, what do you think our products might be? What would the first one be? Sodium what? Sodium fluoride would be the first one, and my second one would be calcium nitrate, right? Okay, but let's go ahead and write them out just so that we have an idea, okay? We've got to build them. So we need our periodic table of ions, so we know what charges they need. Okay, so have this one out if you don't have it out yet. We need to have it out. If you don't have a copy of it, I can get you a copy, but we need one. So sodium nitrate. Sodium is a +1. Nitrate is a -1. So do we need to bother doing the crisscross? No, they go together perfectly, right? So sodium nitrate would be NaNO3. It reacts with calcium fluoride. Calcium is a +2. Fluoride is a -1. So when I build that molecule, what's it going to look like? Ca what? F2. Okay, so there are my reactants. That's what they gave us. We said my products are probably going to be sodium fluoride and calcium nitrate. But let's check here. If I'm looking at a double displacement reaction, I want my outsides to come together and my insides to come together. So if my outsides come together, that would be sodium and fluoride. Okay, so we were right in predicting that. So I can't just come over here and say NaF2. It doesn't automatically get the same subscript. We have to build it from scratch. Okay, so if I want to build sodium fluoride from scratch, I'm going to come up here and I'm going to figure out what sodium's charge is. It's a +1. Fluoride is a -1. So they do what? They go together perfectly, right? They just cancel out. So that means my product would just be NaF. And then my final product would be the combination of calcium and nitrate. So I'm going to come up here and figure out what that would look like. Calcium is a +2. Nitrate is a -1. Where do I find nitrate on my periodic table of ions? In the box, right? It's got to be in the box. 8s and ites come in the box, okay? So now I'm going to crisscross. I drop the plus and minus. And so that looks like CaNO3, just like that. What do I need to have? I got to have parentheses around my NO3 because I'm saying I need 2 of those nitrate molecules to cancel out my calcium. So I'm going to come down here and I'm going to put in my final product. We said it was CaNO3, 2. Okay, so I've built my reaction, but is my chemical reaction balanced? Is it balanced? No. Yeah, Scarlett, go ahead.
Does it matter which one?
No. Okay, it doesn't matter if I would have listed them with this product than this product. It wouldn't have mattered. The only thing that matters is that it has the right partner.
So like if you did NO3, NC2.
Okay, that does make a difference, okay? When we build our formulas, the cation always comes first. Yeah, that's a good question. Okay, so we wouldn't have it NO3 to Ca, right? That's not how we would write that formula, because it always goes cation, then anion. Yep, good question. But in terms of which actual product we list first, that makes no difference at all. Okay, it doesn't matter if we would put calcium nitrate first or sodium fluoride first. Let's go ahead and balance our reaction then. I'm going to start, I don't need to make my list, right? I think we're comfortable enough maybe with balancing now to go without a list. Would you agree? Yes or no? If you are, great. If you're not, fine. Still make the list. No big deal. But I see an obvious thing that's not balanced, right? I'm going to start with my nitrates because I see 2 on the right-hand side. So that means over here on the left, I'm going to start that with a 2. Okay, that balances my nitrates, but what does it do to my sodium? It makes it 2. So I need to come check now on my product side, do I have 2 NAs? Well, I don't, right? So I'm going to put a 2 in there. That changes my fluorine to be 2. So I come check over here and it's already at a 2, which means I'm probably good. Okay, so if you're not going to use the list, that's perfectly fine. Pick an easy change and then let it bounce you back and forth until you feel like you have it balanced, right? And then you can check. But here I started with an easy change, right? I see that nitrates was not balanced, so I moved it there. It bounced me to the product side to check sodium, and then it balanced my fluorines. And then I can check the one element I didn't mess with, which was calcium, and it's good on both sides. Do you see how that speeds up your process a little bit? Okay, pick an easy change. You could have also started right away noticing that I had 2 fluorines and only 1. I would have put a 2 there, which changed my sodiums, which put a 2 there, and I checked to see I already have 2 nitrates. That would have worked as also. Right? It doesn't matter where you start. I just pick an easy change to start with. Okay? All right, now we have a question to answer with this balanced chemical reaction, a stoichiometry type question to answer. So is that printed on your slides as well? Yes or no? Yeah. Is there a a stoichiometry question if I start with 83.2 grams? Okay, let's go ahead and answer that now. I'm going to give myself some room here. All right, so it says if I start with 83.2 grams of sodium nitrate, whoa. Yeah. Sorry. Okay, it says if I start with 83.2 grams of sodium nitrate, how many grams of calcium nitrate will be produced? So now we're doing a gram to gram conversion, right? Just like we've been practicing. So I'm going to start with 83.2 grams of sodium nitrate, and I'm trying to find grams of calcium nitrate. All right, so I'm going to do a stoichiometry problem. Let's remind me, how do I go from grams of one to grams of another? What's my middleman have to be? Has to be moles. So I'm going to go from grams of sodium nitrate to moles of sodium nitrate, then moles of calcium nitrate, then grams of calcium nitrate. So let's go ahead and get that written out. Okay? 83.2 grams of NaNO3. And I'm going to convert. I have to cancel grams of NaNO3 first. And I'm going to go to moles because we said moles is our middleman. So moles of NaNO3. That becomes the next thing we cancel. NaNO3. And we said we wanted to switch now. CaNO3 right? Because what's this step called? What's that one called right there? Mole ratio step. And that's the only place where we can switch compounds. The only place we can switch compounds. Okay, then my final step would be to cancel moles of CaNO3 or calcium nitrate and go to grams of that. If you like to put in your numbers as you go, that's perfectly fine too, right? I just want to make sure all my units are in the right spot, and then I'll go back and put in my numbers. But if it makes more sense to you to put the numbers in as you go, that's perfectly fine, okay? But let's go ahead and look at what numbers need to go in here. Between moles and grams, what's my conversion factor here? What goes with grams? Molar mass of NaNO3. So if you don't have your calculator out, go ahead and grab that out. And we want to calculate molar mass of NaNO3. I got somewhere around 85. Okay, and in this step, what does moles always get? The 1, right? In this step right here, this is always 1, okay? Yes. It'll kick off. All right, now in this step right here, where do we get our numbers from? The mole ratios. Good. So calcium nitrate's on top. What's it going to get? 1. And sodium nitrate's going to get a 2, right? Those numbers come directly from the coefficient in the formula. All right. And then down here, moles goes back to getting the 1. And we need molar mass of calcium nitrate to go there. I got about 164 for my molar mass on that one. Okay, calcium nitrate's molar mass, CaNO3 means I took calcium, which was 40, plus 2 nitrogens, plus how many oxygens? 6 oxygens, right? These numbers are coming right off the periodic table. 40, 14, 16, those come right off the periodic table. I got 164. Is that what you guys had? Or is it different? That's what you had? Okay, so now I'm going to make sure my units cancel. One more time. Grams of sodium nitrate cancel. Moles of sodium nitrate cancel. Moles of calcium nitrate. I'm left with grams of calcium nitrate, which is what I want. So now I multiply across the whole top, divide by the whole bottom. Oh, no. I got 80.3 grams of calcium nitrate. When it asks me about mass, what does that mean my units are going to be? Grams. I'm really going to grams.